Alright, welcome back. MN4153 System Programming. So in this particular video, we're going to see an introduction to system programming. So what we're going to do is to actually recap some of the things that probably you have learned in your first year, basically on ITP, Introduction to Programming, on operating system, and some info on Linux operating system as well, which probably have covered in OS course as well during your first year. Now, who are these people actually? I think if you are into open source and also C programming, probably you have seen some of these faces. They're actually very key people in the world of computer science and also programming and also open source. Now, the first person on the left of the screen, this is Linus Torvalds. I'm sure you can guess by the name, and probably you have heard about Linus Torvalds. He's actually the inventor of the Linux operating system. Well, it's actually not an operating system, it's a kernel, which I will explain later. Now, the second guy, he is Richard Stallman. He is the one that promotes the idea of free software, which is related to open source. The third and the fourth, this is related to C programming. So these two key people are the one that created the C programming language back in 1970s, Dennis Ritchie and Ken Thompson. And in fact, if you search about C programming textbook, you're probably going to see one of the earliest textbook on C programming and still being used, which is Introduction to C Programming by Dennis Ritchie and Ken Thompson. Or we can have a look online and see whether we can search about these two gentlemen. Dennis Ritchie and Ken Thompson. C programming. So this is actually one of the earliest programming textbook for C programming, written by Dennis Ritchie, and there's another guy called Brian Kennedy as well, who is also the inventor of the C programming language. And the last person, Eric S. Raymond, is also related to the open source software movement. I think the difference is you can find a book written by Richard Stallman, which is The Cathedral and the Bazaar. So Richard Stallman, The Cathedral and Bazaar. This is his face when he was much younger. And his idea about open source is actually probably different from what a lot of people think. When he mentioned that software should be free, it doesn't mean that he is asking people to create the software for free, but what he stated is that software is the right of everybody, meaning that you should be able to write any software and anybody should be able to use that software for their own purpose, and this is related to freedom actually. So he actually created or written this book. I'm not sure we can find this in the bookshop in Kuching, Popular or my bookstore. Of course you can buy this online, but it's actually quite interesting actually. So if you are into open source software or the free software movement, FSF, and you can probably have a look and read some articles online about Eric S. Raymond and also Richard Stallman. So these two actually wrote the book on the Cathedral and the Bazaar. But the key thing is, all of them in some way contribute to system programming. Linus is the one that created the operating system, Linus Torvalds. Alright, let's look at computer system in general. This is the term that we use, computer systems. And what it is actually consists of hardware and software. So that's the keyword, consists of hardware and software that work together to run application program. So if you look at this diagram, it's a generic diagram that explains about computer system. So computer system should consist of two components. We must have a software and we must have hardware. So there is no computer system that have only one of those actually. So to benefit from a computer system, you should have both the software component and the hardware component. And later we're going to see the software can be divided into application programs, which is the high level program, and operating system, which is the system level program. And hardware, of course, there are various hardware components in our computer system. Can be processor, the RAM, the memory, the I/O input output, and so on. So again, this is just to differentiate between two types of software. So if you look at this diagram, what we have on the outer layer, the green layer, is what we call as the application software. These are the software that the user interact with. You can see spreadsheet like Excel, word processor like the Word, or Microsoft computer games that you like to play, PUBG, Fortnite, and ML, databases, internet browser, and so on. So we have a lot of software which is used by the end user, and this we categorize under application software. And another category of software is what we call as the the system software, whereby example is that operating system, and we have other system software utilities that the system use from time to time. And at the heart of the computer system, as what we've seen in the previous diagram, is actually the hardware. So the whole thing is actually a computer system which consists of software and hardware, whereby for software we have two types of software. We have the application software and the system software. Now these are the differences between system software and application software. Now if you look at the first one, what is system software? Is used for operating computer hardware. So meaning that when you are given the hardware, RAM, the processor, the input output, they are actually useless without system software. So there must be something that the end user can use in order to utilize or use this hardware. If you look at application software, what is the purpose of application software? Application software is used by user to perform specific tasks. If you want to write a report, then you use the word processor, Microsoft Word. If you want to calculate something, then probably use Excel. If you want to create a presentation, PowerPoint, and so on. So basically, application software is any software that is used by the end user to perform specific tasks. What else? The difference between system software and application software? You can see that system software are installed on computer when operating system is installed. Application software are installed according to user requirement. So when you have your computer that you purchase, either a laptop or desktop, you have your operating system installed inside there. It doesn't matter whether it's a Windows, Microsoft operating system, or it can be a Mac, or it can be Linux, and so on. Now, the third difference between system software and application software is that for system software, the end user, does not interact with the system software because it works in the background. So most of the time you interact with the application software, but you don't really interact with the system software. It's running there in the background to perform something without probably the knowledge of the end user. As compared to application software, as I mentioned, you interact with application software to achieve a certain task or goal. The fourth differences is that system software can run independently, whereby you cannot run application software independently. So meaning that in order for you to install and use application software, first you need to have operating system, which is a system software. So you have your system software in your computer, then inside the system software you install your application software. And the last one, just some examples of system software. When you do your programming, either C programming, C++, and so on, you are actually using the compiler, which is the system software. Assembler, which is a low level. For network student like you, I think you use assembler or assembly language in your microfield subject. And you also have debugger when you debug certain in certain programming language or in certain software for programming language, driver for hardware, and so on. So those are some of the examples of system software. And for application software, as I mentioned, there are various applications that you install and use in your computer. For example, word processor, spreadsheet, presentation software, browsers, and so on. Now, the next thing that we want to see is about operating system. So you have actually go through in detail about operating system concept in your first year, second sem if not mistaken. But what is meant or the definition of operating system? Now, operating system is a program, as we discussed previously. Operating system is a system software. So it's actually a program that acts as an intermediary. So this is actually very important. So remember, in your exam, either midterm or final exam, you can be asked about definition of various terms in our course. So this is probably one example. What is an operating system? So operating system is a program that acts as an intermediary. So it's like a middleman between a user of a computer and the hardware. So basically, you have your hardware, and in order for you to use that hardware, you need to have operating system. So it acts as an intermediary, a middle person or middleman between the end user and the hardware itself. Now, why you need operating system? Because you can execute user program and make solving user problem easier. Have you seen in previous slide? In order for you to run application software, you need to actually install that in an operating system. And the second goal for operating system is to make your computer system convenient to use. So when we have hardware in our computer system, for example, processor, memory, hard disk, and so on, it is probably possible to use them directly, but it's going to be very, very difficult. As you have seen in your micro-P course in your second year, just to perform a single task like moving something require 3 to 4 lines of code. So it's actually very, very difficult to access the hardware directly, low level. So we need an operating system to make the whole computer system convenient to use. And the last one, when we have the hardware, it has to be used in an efficient manner, and operating system allow you to do this. So where do you find operating systems actually? So this is quite interesting. Now, beside the common computer system that we always think of, which is desktop and laptop, I think most of you have smartphone. So that is actually a computer system. Because if you look at the definition of computer system consists of code, software, and hardware. So where else we can find operating system actually? If you think about a car, a modern car, you can find software and you can find hardware as well that can drive a car. So that is actually a place where you can find operating system. Embedded system, and we talk about the latest development like IoT, Internet of Things. There's a lot of embedded system that have both the software and the hardware. So there's a lot of embedded system actually, ranging from a smart home, smart TV, and so on. So all those have some sort of operating systems built in inside to ensure that you can use the hardware in efficient and also easy manner as well. So operating system has these features. I think you can go through this yourself. This one is just to recap. It has memory, file systems, resource naming and location, can do multitasking, running multiple tasks at the same time, communication, synchronization, and so on. Now let's look at one of the operating system available. I'm sure most of you use Windows operating system. I think according to statistics, Windows operating system consists of 94% of the whole operating system being used all over the world. So it's actually a very huge number. And even though there are other type of operating system, but they are actually very specialized in certain areas. Now, One operating system that was very popular at some point in the past is actually Unix operating system. So Unix is actually an operating system. It was created in AT&T Bell's labs in US back in 1960s, 1970s, and it evolved into one of probably the most powerful and popular Unix operating system called System D. And this is actually being used in a lot of mainframe computers um, back then. And this mainframe is being used in various areas such as finance, banking, research, military, and so on. Now, the key is that's why we was looking at the people important in this area, Dennis Ritchie and Ken Thompson, because Unix is fully written in C language. And there is a reason why C language is still very, very important, especially for network students. If you look at C language, it was created mainly for embedded system. So you can actually run C language in many embedded systems. Of course, you can run C language in any computer system, but it's actually very efficient for low-level programming language, and that's the reason why we choose C language as the key language for system programming subject. And the last point is that it's easy to port to different hardware platforms for Unix operating system. So you can have something like the sys platform. If you still remember your computer architecture, complex instruction set computers, and also reduced instruction set computers. So we have different type of hardware platform, and you can actually port or convert Unix to run on different platforms. Now this is one example, 1969, many years ago, one of the system that runs Unix called PDP-7. It's huge. Probably your Casio FX calculator is more powerful than this. You can see that it has oscilloscope actually. This is the terminal where you input data using punch card. This is probably the memory section, and it's actually in kilobyte rather than megabyte or gigabyte. The processor is probably somewhere here, and probably the processor is slower than your current calculator, and the RAM is probably in the range of byte or kilobyte. So it's a huge computer, but the key is that it's running Unix back in 1969. Now, what is Linux actually? So this is quite interesting, history of Linux. And if we go back to the list of people just now, it was created by Linus Torvalds. And Linux is a freely distributed implementation of a Unix-like kernel, the low-level core of an operating system. Now, what it is, and this is actually a lot of misconception, Linux actually is not the operating system. Linux is actually a kernel within an operating system, and there is a difference between kernel and operating system itself. So Linus Torvalds, when he was a student at the University of Helsinki, if I'm not mistaken, and he was 21 years old during his undergraduate study at the University of Helsinki, and when he took one of the subjects, and he was thinking, why can't we have an operating system which is easy and free to use for, let's say, education purpose? Because during that time, only the Unix operating system was available, and Unix is actually not free. You have to pay license to use it, and so on. So Linux actually take inspiration from Unix operating system, and there is another operating system called Minix, and he actually started to write his own kernel. And the next thing what happened is that he actually shared the very first kernel online in one of the what you call as chat group, Usenet group actually. It's not like WhatsApp, but it's Usenet. And he actually asked people to try it and give feedback, and that is the start of the open source movement. So basically, open source, you created a software, you post it online, people actually use it and give feedback, and people contribute to improve. So he started to get feedback from people and started to get suggestions from people what need to be added, because it's actually a bare bone kernel. So it doesn't have any network capability and so on. So people start asking, why don't you put element for networking inside there? And he actually did that. And the group become bigger and bigger, and people start to use it and so on. So this diagram, not to worry about this, it looks very complicated, but what it shows is actually the history of Unix and Linux. You can see this is the birth of Linux back in 1991. I'm sure a lot of you were not born yet in 1991. And I mentioned there was similar operating system called Unix, and of course Unix started somewhere here with different name, and it branches out to different variation, actually different version of Unix. So there is something called BSD Unix, there is Sun OS, HP Unix, and so on. So Linux is here actually. So this number indicate the kernel number or the kernel version. And currently I think the latest kernel version is 3.9 if I'm not mistaken. Now this is probably something that you are familiar. When we talk about Linux, there are a lot of different distributions. And this is something very interesting actually. You can go to this website and look at what is the latest top ranking distribution. Maybe you should go there. So let me switch to the browser. Where is the browser? Very strange. Okay. Let's go to Google, or you can type straight away distrowatch.com. And you will see this website. What you can see actually on the right hand side of here, which is the list of the top ranking distribution. Manjaro is the first one, Mint, Elementary, followed by Ubuntu on the fourth place. Of course, this changes from time to time. Every week I think they will update that. Some of these have actually tried personally. Ubuntu, Debian, Fedora, and so on. And for sure you have probably tried this as well. I'm not sure which distribution that you use for your operating system software. It's either Fedora or Ubuntu. But what is distribution actually? Now, as I said, Linux itself is the kernel. After this, we're going to see some slide that describe what is the kernel. And this is related to open source. So meaning that open source software, anybody can use it for free. Anybody can make changes to the source code. But the rules for open source, if you make any changes, you have to give back the changes, or you have to share back the changes. And you cannot sell the software itself. So distribution is when an organization or company, they take the kernel, which is the heart of the operating system, and they start to add things around the kernel. So for example, if I want my Linux distribution to focus on multimedia, so you add library or component that deal with music, video, and so on. If I want my distribution to focus on security, then you add a lot of tools for security, penetration testing, and so on. Maybe I want my distribution to be a general purpose operating system like Windows. Then you put a lot of things like word processor and so on. So Ubuntu, for example, is a distribution by a company from South Africa. And the main aim of Ubuntu and also Fedora is actually a multi-purpose or generic operating system. So you can use Ubuntu for everyday tasks actually, similar to Windows operating system. Mint, for example, also try to focus so that the user experience is similar to Windows. So if you are from Windows operating system and you go to Linux Mint, and that is probably almost the same experience. The start bar or the taskbar is the same, the look and feel is the same, and so on. There are some operating system focused on specific tasks. For example, Debian is usually used for server side. Ubuntu, of course, they have their Ubuntu server edition as well, the one that we use in our course. There are distribution for security, Kali Linux, and so on. There are distribution that focus on um, media player, and so on. So that there are a lot actually. There are thousands and thousands of distribution, and the thing is, you can create your own distribution if you want to. There are a lot of tutorials online on how to create your own distribution. So just an analogy actually. If you look at Linux distribution, similar to a car. So for a car, the heart of a car is probably the engine. So you can think kernel or Linux kernel as the engine. And then people can create a sport car. So they start to put the design, the front part, the back part, and things like that, suitable for sport car. Then people start to maybe want to have a SUV. So the engine is the same, but what you put around the engine is different, and that is what we call distribution. So distribution is one way for an organization to create an operating system specific to certain tasks or purpose. So probably we should look at the internet for a definition of distribution. So what is a Linux distribution? Let's try Wikipedia. Oh, there is one here actually. So let me zoom in. A Linux distribution is an operating system made from a software collection. So this is what I meant. So the heart is the kernel, and you can take a kernel and put a collection of software for a specific purpose. So if you want to make it into a multimedia distribution, you install or put software collection related to multimedia and so on. So you can use this as the standard definition if there is question in the exam. The Linux distribution is an operating system made from software collection. As simple as that. Let's move on. Why Linux, not Windows? Even though, as I mentioned, the percentage of usage for Windows is actually quite high, around 94%, 93%. But Linux still actually have a lot of usage in certain areas. Now, if you look at this statistic, it's actually a very old statistic. I haven't got time to update this. Windows is still very high compared to others. And we have for mobile operating system as well. And of course, now Android is actually the highest. During this time, 2012, Symbian, which is from Nokia, if I'm not mistaken, is the highest, but now it's actually Android. But why Linux? Now, I think the beauty of Linux, you can get Linux distribution or operating system for a wide variety of computer systems. As we discussed just now, it's just not limited to desktop or laptop, but you can actually get Linux for any type of system. It can be embedded system, it can be a TV top, it can be Raspberry Pi, it can be for phone as well. So there are various platforms which is supported by Linux. And the last statement is that if you got a processor, someone is probably trying to get Linux running, which is true. You can get a lot of really unique computer system, and probably someone have tried that. Now, if you look at the list of operating system here, Android is actually a mobile OS, Mac, which is for the Apple operating system, iOS is actually for Apple mobile system. If you look at the core of all these operating systems, the heart is actually a Linux kernel. Android is using a Linux kernel, Mac OS is using a Linux kernel, and so on. Of course, they add their own library and functionality and so on, but the heart of it is still a Linux kernel. Now let's look at the architecture of an operating system. So as I mentioned, when we talk about Linux, it's actually a kernel. So kernel is actually the center or the heart of any operating system. So if we start from the inside, which is the kernel, and around this kernel we have system call, which is what we're going to focus for our course. And then what we have is the application layer on the outside. So remember we discussed about two types of software, application software and also the system software. So application software on the outside, and then we have the system software in the inside. And operating system actually consists of the kernel plus system calls and other things actually. So kernel is actually part of operating system which is responsible for all other operations. So that's the definition of kernel. Kernel, part of operating system, responsible for all other operations. So any operation within an operating system is actually handled by the kernel. So that's the heart of the OS. The primary function is actually to manage computer resources and allow other programs to run and use these resources. So these are the two primary functions of a kernel. It allows other users or programs to use these resources, and the first one is actually to manage computer resources. So what is resources? Processor, RAM, hard disk, I/O, and so on. And kernel is also responsible for synchronization, something that we're going to see in detail in this course, and also communication between processors called IPC. Again, something that we will focus as well. Now, it's not limited, the term kernel is not limited only to Linux operating system, but also applies to any operating system actually. So if you are using Windows, there is actually Windows kernel. If you are using some other operating system, they have their own kernel as well. So basically, kernel is just the part of operating system that is responsible for all operations. So if you look at Windows, if you are as old as me, probably you have used starting from Windows 3.0 and then Windows 95, 97, 98, ME, XP, Vista 7, and now the latest one 8 and also 10. That's the latest one. There is another kernel which is focused on the server operating system, also from Microsoft, the Windows NT kernel, and so on. So just another visualization of a kernel. So kernel is the bridge between the application layer and the hardware layer at the bottom here. So just another view of kernel actually. So these are the basic facilities of a kernel. It will manage a process management, memory management, device management, and system call. And this is probably related to our course. What we're going to see in details in our course is actually the middle part. So above is actually the application layer, bottom is the hardware layer, and within the kernel is something that we will go through in this course. So we're going to see a lot of system call. We're going to focus quite a lot on the file system, input-output. So LU1.1, 2.2, and 2.3. We're going to look at process and process management. We're going to look at some memory management as well, and so on. So we cover most of the middle part within the kernel using system programming. Now finally, what is system programming actually? So that's what we're going to focus in our course. The title is system programming. It's actually an art of writing system software, which is different from application software. So we discussed about two types of software: application software, which provides service to the end user, and system software, which provides service to the system itself. So the aim of system programming is to produce a software which provides services to the computer hardware. So the purpose is different actually compared to application software. The one that you did in your first year when you took ITP, Introduction to Programming, is mainly to use C programming language to create high-level software or high-level application. And the aim of those applications is usually to serve the end user. So it doesn't matter what kind of application, but the aim is usually to support or help the end user to achieve the task. But system programming is different. We focus mainly on writing software or program that provide services to the computer hardware itself. Why system programming? Well, I guess this is very subjective, especially the last part. To some people, including myself, it's fun. I think a lot of people are scared of programming, but as I said, we'll try our best to probably help you to learn programming after this course. The rest you can read on your own. Now, the key thing for system programming, there are three components or three cornerstones. When we do system programming, we have to deal with system call. We're going to learn a lot, around 40 to 50 system calls throughout this course. Of course, you're going to use the C library and we're going to use the C compiler. So these are the three things when we deal with system programming. What is system call? We're going to learn about system call later. System call, also sometimes called as syscalls, function invocation. So there are four parts of this definition. System call function invocation made from user space into the kernel in order to request some service or resource from the operating system. So four components of this definition. This is something definitely come out in the midterm exam. System call is function invocation, number one, from the kernel, from the user space into the kernel to request services or resources from the operating system. So make sure you memorize this definition for system call. Function invocation from user space into the kernel to request for services or resources. What is user space? User space is actually what you use in the application layer, text editor, game, word processor, and so on. So again, another illustration of the whole thing. So we have the kernel in the middle. We have system call. System call is function invocation from the user space up here into the kernel to request for resources or services. So the resources or services is actually the hardware and so on. I'll come back to this diagram later on to link the difference between system call and also library function. Library function is the high level function that you use in your introduction to programming in the first year. System call is actually a direct access to the C library that we have. So the C library, the second component of system programming, is the heart of Unix application. I think you use library quite a lot in your ITP, studio.h, sys.h, and mac.h, and so on. We're going to use C library provided by GNU libc, abbreviated as glibc. You're going to install this in your computer using the virtual software. And the last component for system programming is the compiler. We're going to use GNU compiler, GCC. And this is actually one of the open source compiler for C programming language. The one that you use for your introduction to programming is probably slightly different, but still achieve the same thing. Now, why C language? That's what I discussed earlier, is the language of system programming. So if you want to be computer system programmer, C is actually probably the best one. Most of the major operating system in Linux, BSD, OS X, which is from Apple, and Windows, even for Windows, the core is actually written in C. Why? Because C is actually very, very fast. And if you look at SourceForge, one of the websites that compile a lot of projects, 1/3 of the project is actually C or C++ based. So it's actually a very, very popular programming language, even though there are a lot of other newer programming language like Python, Java, .NET, and so on. So the rest of the course is going to cover this in details. You can refer to the study guide later on to look at how we go through all this in our 14 weeks course. So just to recap, basically we have looked at some of the past theory that you have covered in your previous year. So basically we have looked at operating system in general. We have looked at what is Linux operating system, Linux distribution, what is a kernel, and what is system programming in general, which consists of 8 things: the system call, the C library, and also the C programming language. So that's it for this video lecture, and I'll see you in the next video or during the lecture. Thank you.